Okay, picture this. You're tasked with designing the battery system for a next-generation electric vehicle. Now, if you base your entire design on just one single research paper, you are almost guaranteed to build a faulty, dangerous, or completely inefficient product in the real world. Why? Well, because complex engineering decisions demand a foundation built on robust, heavily evaluated evidence, not just one isolated data point. But let's be real here. Staring at a massive mountain of research papers is incredibly overwhelming. It's so easy to just get lost in the weeds. So, welcome to this explainer video. Today, we are completely transforming how you approach the literature review. We're going to move away from that amateur habit of just collecting paper summaries and instead learn how to truly synthesize existing knowledge to push the boundaries of what is actually possible.
All right, here's our roadmap for today. Number 1, beyond the simple summary. 2, finding the right evidence. 3, extracting the core data. 4, the 6 critical questions. And finally, 5, finding the research gap. Let's get into it.
Section 1. Beyond the simple summary.
Look, this is where we have to dismantle the most common mistake out there, that terrible habit of just listing paper summaries one right after the other. To get started, let's look at what we're actually trying to achieve here. A literature review is not just Googling a topic so you can prove you read some articles. Not at all. It's a rigorous, systematic examination and synthesis of published research. You're trying to deeply understand the existing knowledge, compare completely different technological approaches, and critically identify research gaps. Think of it like constructing a building. This review is the evidence-based foundation you absolutely need before making any complex engineering or design decisions, because if that foundation is weak, your final product is going to collapse.
And this brilliantly illustrates the exact mindset shift you need to make right now. A basic summary simply states that paper A designed a solar dryer using forced air. Okay, well, that just tells me what one person did. It's basically a book report. But a professional literature review, that synthesizes the whole landscape. It says that paper A used forced air and paper B used thermal storage. However, neither evaluated high humidity conditions. Do you see the huge difference there? Synthesis actively compares multiple approaches and instantly identifies a gap in real-world application. It naturally begs the question, what happens when it rains? And you know what? That is exactly where your engineering work begins.
Section 2. Finding the right evidence. Now that we know what a review actually is, let's talk about the mechanics of finding your research. The goal here is strict relevance. It is not about amassing the largest possible pile of PDFs on your hard drive that you're inevitably never going to read. We have absolutely all been there, right? Hoarding digital files like a pack rat, somehow hoping that just downloading them transfers the knowledge into our brains. Read this quote carefully. Finding 100 papers does not mean you have conducted a good literature search. Blindly downloading every single paper you see after a broad database search is a massive, time-wasting mistake. A genuinely good search is focused, highly inclusive of technical synonyms, and incredibly iterative. Complicated search strings aren't inherently better. They're really only better if they efficiently pull in relevant, high-quality literature without all that extra noise.
So, to avoid drowning in irrelevant papers, you've got to use this ruthless 4-step screening sequence. First, look at the title. If it's not directly related to your specific engineering problem, toss it immediately. Second, screen the abstract. Does it use a method relevant to your study? If not, stop reading right there. Third, jump all the way to the conclusion. Does the final takeaway actually align with what you need to know? Finally, and only if it passes all 3 of those rigorous steps, do you sit down and do a full paper assessment. The absolutely crucial point here is that you must constantly ask yourself if the paper is truly relevant to your core research question before you invest your highly valuable time reading the whole thing.
Section 3. Extracting the core data.
Okay, once you've ruthlessly screened those search results, you'll be left with a finalized, high-quality stack of maybe 10 to 20 highly relevant papers. But how do we actually process them efficiently? Well, the order of operations here is super fascinating. Reading a complex research paper is not like reading a textbook chronologically from page 1 to the end. You start with the title and abstract, sure, but then you skip straight to the conclusion. Reading the conclusion first quickly reveals the researcher's main findings and, crucially, their admitted limitations, telling you immediately if it's actually worth digging deeper. Next, look really closely at the visual data, the figures and the tables, because honestly, data rarely lies. Only then, after you understand the beginning, the end, and the data, do you dive into those dense, heavy methodology and result sections. Now, as you're reading through those methodologies, you need a bulletproof system. Enter the Literature Extraction Database. This is your ultimate tool as a researcher. Basically, for every single paper you read, you create a row in a spreadsheet, capturing the objective, the methodology, the results, and the limitations. But here is the real secret to making this work. You have to write these out in your own words. Absolutely no copying and pasting from the PDF. Paraphrasing into this table prevents accidental plagiarism, it actually forces you to understand the material you just read, and it completely eliminates that familiar nightmare of staring at your screen a week later, totally forgetting which paper said what.
Section 4. The 6 critical questions.
So we've extracted the raw data. Now we have to analyze it. Okay, let's dive into this. And view this specific framework as a professional weapon to evaluate the information you've just meticulously gathered. These 6 questions will elevate you from merely describing a paper to actively analyzing its worth in the field. 1. What exact problem is being solved? 2. Why was this specific method chosen over the alternatives? 3. What hidden assumptions did the researchers have to make to get their results? 4. How does this differ from previous work in the same field? 5. What are the limitations? And 6. What future work is suggested?
I actually want to isolate question number 5 for a moment. What are the limitations? When you're reading a paper, please do not view a limitation as a failure or a weakness of the researcher. Instead, you need to view limitations as boundaries. Maybe a highly touted machine learning model achieved incredibly great accuracy, but it was only tested on a very small, controlled laboratory dataset. That specific boundary is exactly where real-world engineering innovation breeds. Your entire job is to find those boundaries so you can break right through them in your own work.
To prove that point, let's look at how we talk about those boundaries. A weak critique just says, the method is not good. Well, that tells us absolutely nothing actionable. But a strong, evidence-based critical analysis, that says, achieved high accuracy, but the requirement for large datasets limits use in resource-constrained environments. Now that is incredibly powerful. It directly informs your future designs and real-world implementation by highlighting the exact barrier that needs to be overcome next. You now know, for sure, that you need to build something that works with small datasets.
Section 5. Finding the research gap.
We're now entering the final and definitely the most advanced stage of this explainer. This is where you synthesize your critical analysis to find the missing puzzle piece in your field. Let's move to and see how this builds directly into your final output. Instead of a weak, repetitive, paper-by-paper structure where you just state that paper A did X and paper B did Y, we're going to utilize a thematic synthesis. By grouping papers by their thematic relationships, say comparing the high accuracy of one computer vision model against the rapid speed of another, you reveal the true narrative of the research. You are telling the fascinating story of the entire field, not just reading out the stories of individual, completely disconnected papers.
To achieve this thematic synthesis flawlessly, you should really build a comparison matrix just like this one. By mapping out the approaches, their specific advantages, and their limitations right side by side, you visually expose the ongoing trends in the research. You can instantly see that while deep learning offers incredibly high pattern recognition, it's fundamentally bottlenecked by the requirement for massive training datasets. On the flip side, traditional vision relies on low computation, but is far less adaptable to environmental changes. This matrix is literally the key to unlocking the field. It's what ultimately uncovers exactly what complex engineering problems remain insufficiently solved.
Once you clearly see those unsolved problems mapped out, you can write a professional gap statement using this exact formula. Existing knowledge plus identified limitation plus need equals your research gap. It's a perfect logical flow. Let's look at an example. Previous studies have used deep learning for robotic vision. Okay, that's your existing knowledge. However, most evaluations are conducted under strictly controlled lighting. There's your identified limitation. Therefore, further research is required to develop robust models for varying, unpredictable industrial environments. That is the need, and ultimately that is your research gap.
And that brings us to our final challenge for you. The days of simply collecting and repeating paper summaries are over. You now have a systematic, highly structured framework to find the right evidence, extract the core data, analyze it critically, and synthesize it into a truly compelling narrative. So stop summarizing. Start asking the critical questions. Find those absolute boundaries in the current research, and ask yourself, what unknown will you discover? Thanks for joining me on this explainer, and I will catch you in the next one.